Hello everyone, I'm Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will discuss about Allan Robinson reaction. In this reaction, flavone or isoflavone will be synthesized by reacting alpha hydroxyketone with acid anhydride in the presence of base. This is alpha hydroxyketone. When alpha hydroxyketone react with acid anhydride in the presence of base, it results in the formation of flavone or isoflavone. Let's have a look to the reaction mechanism of this reaction. In the first step, base will abstract alpha hydrogen atom of alpha hydroxy ketone. As we already discussed in the Aldol condensation reaction, that alpha hydrogen atom of aldehyde or ketone are acidic in nature. Due to this reason, when it is reacted with base, base will abstract this alpha hydrogen atom and it will result in the formation of enolate. If we look at the structure of enolate, this is enolate, and then it will gain one of the proton and will give enol. So in the first step, it will result in the formation of enolate, and then it will convert it into enol. In the next step, base will abstract this enolic proton, and this is the enolic proton. So base will abstract this enolic proton, and as a result, this enol, the carbon-carbon double bond of enol will attack on acid anhydride, and the bond will be break toward oxygen atom, and it will get negative charge. And in the next step, this negative charge will be reformed to the carbonylic functionality, and this carboxylate group will be removed. Carboxylate. So by the removing carboxylate group, it will convert it into ketone. So this is the ketonic functionality. By the removing of a carboxylate group, ketone functionality is formed. In the next step, base will abstract this alpha hydrogen atom of this dicarbonylic functionality. If we compare this carbonylic functionality with the first one, this is the substrate or first carbonylic functionality. So this alpha hydrogen is less acidic than this alpha hydrogen atom. Why? Because in this case, two electron withdrawing group is attached, and in this case, one electron withdrawing group is present. So due to this two electron withdrawing group, this alpha hydrogen atom becomes more acidic and it can be easily enolized. So base will abstract this alpha hydrogen atom much more easier than the first one. So as a result, in the first case, it converted into enolate, and then by gaining one of the proton, it will convert it into enol. In the next step, this carbonylic functionality will be protonated, so it will get positive charge. If we talk about this carbonylic functionality, so now this oxygen atom is positively charged, it will get much more electron towards or withdraws electron much more towards itself. So this carbonylic functionality or carbon atom becomes much more positive. So due to this reason, this alpha hydrogen atom, this oxygen atom of alcohol or phenol will attack on this carbonylic functionality, and the bond will be breaks towards oxygen atom. As a result, cyclization takes place. As a result, cyclization takes place. So in the next step, this oxygen have lone pair of electrons, so it will gain one of the proton, and this becomes positively charged. Then in the next step, a base will abstract proton of this enol, and it will form this carbonyl functionality. So the pi bond of this alkene will be shifted to the next carbon atom. With the removal of water molecule, it resulted in the formation of flavone or flavonol, isoflavone. So here water molecule is removed. So what type of reaction is this one? Dehydration reaction. So because of this dehydration reaction, isoflavone or flavone is generated. Let's have a look to the example of such type of reaction. In this reaction, when alpha hydroxy ketone or uh, other functionalities are reacted with base, so base will abstract this alpha hydrogen atom, and then this alpha hydrogen will be converted into enolate, and it will attack on this acid anhydride. With the removal of carboxylate and after cyclization, this target compound here will be generated. And in the next example, here heteroaromatic ring is attached to the ketone alpha position of this ketone. So base can easily abstract proton at this alpha position. So enolate will be generated, and then this enolate will attack on this anhydride. So it is cyclic anhydride. The bond will be open up, and it will be converted into carboxylic acid, and after cyclization the target compound will be synthesized. If you like the video, please like, and if you have any type of question, please comment, and also share the video with your friend. And if you didn't subscribe my YouTube channel, so please subscribe the channel. Thank you very much. Allah Hafiz, Allah Paman.